Hello viewers, welcome back to our YouTube channel. So we are continuing our lessons on the properties of binary operation. But before we move on to the next property, we are going to solve one question on the closure property. So we've been given a set P to be equal to 2, 4, 6 and 7. Then we've been given a rule for the operation dot to be A dot B is equal to B minus A. So show if P is closed under the operation dot. That's the question. So it means that whenever we take two elements from the set we've been given and apply the rule to the two elements, our result should be from the set. So now let's take any two of the elements, say let's take 2 and 6. So if we take 2 dot 6, we should get from the rule, we should get 6 minus 2, which is 4. And we see that 4 is in the set. Let's take another number. So let's take, say, 6 and 7. So 6 dot 7. Per the rule, we should get 7 minus 6, which is 1. But 1 is not in the set we've been given. So far as you've gotten just one element which is not in the set we've been given, you just conclude that P is not closed under the operation because just one element or just one output we are getting is not in the set we've been given. So from here you conclude that P is not closed under the operation dot, because when we took 6 and 7, we are getting 1, which is not in the set. And we learned that from closure property, if we take two elements within the set and we perform the operation on it, our output we are getting should also be within the set. And since for this one, just one element is not within the set, we conclude that it is not closed. You can try for other numbers and you realize that you get other numbers which are not in the set, and hence the set P is not closed under the operation dot. So we move on to the next property, which is the commutative property. So commutative refers to a property of certain operations where the order of the operands does not affect the result. So basically for commutative property, it's like if we change the order of the elements we are dealing with or the order of the inputs we are dealing with, it doesn't affect the result. So if it affects the result, then we say it is not commutative, but if it does not affect the result, then it is commutative. So let's take it that you are wearing a shirt, right? You are dressing, you are wearing a shirt and then a trouser. If you choose to wear your shirt first before the trouser, and if you choose to wear the trouser first before the shirt, you are going to get the same result. But if you are wearing a shirt and a vest, and you say that you are wearing the vest first before the shirt, and now you change the order and say that you are wearing the shirt first before the vest, you are going to get totally different output. You wearing the shirt first before the vest and wearing the vest first before the shirt is a whole total output. Hence, for the shirt and vest scenario, we say that it is not commutative, but for the shirt and the trouser scenario, we say it is commutative because you are going to get the same output. So that's how the commutative property is about. So if an operation is commutative, we say that changing the sequence of the numbers involved doesn't change the outcome. So if I'm adding, say, if I'm adding 1 plus 2 is equal to 3, right? Then 2 plus 1 is also equal to 3. Now we've changed the sequence of the numbers involved and our output is the same for addition. If we have also let's say 3 times 2 is 6, 2 times 3 is also 6. This one too, our output is not changing, so it's commutative. But if we have 3 minus 2 is 1. Then 2 minus 3, -1. So since after changing the sequence of the numbers involved, our output is changing, we say that subtraction is not commutative. Let's check for division too and see. If we have 6 divided by 3 is 2, right? Then if we have 3 divided by 6, that is 1 over 2, 0.5. Now 2 and 1 over 2 is totally different. Hence, we say that division is also not commutative. So we are going to see some examples on how commutative questions can be asked. So if, say, we've been given that for a set of raw numbers, a dot b is equal to a plus b plus ab, and they are saying we should show if the operation dot is commutative or not. If the operation dot is commutative or not. So now they've given us a dot b to be a plus b plus ab. So let's change the sequence of what you've been given and see if you are going to get the same result. So here, if you change the sequence to b dot a, you are going to get b plus a plus ba. Now we know that a plus b is equal to b plus a. We also know that a times b is equal to b times a. So from here we can say that this and this are the same. Then also ab is the same as ba. So since after we change the order of the elements involved, our result is the same, we say that the operation is commutative, the operation dot. So here the operation dot is commutative. Dative. So the operation was given to us on a set of real numbers. So let's try and use any two real numbers and see if our result is going to be the same. Because we've already proved with the variables that it is commutative. But then we just want to use numbers to solve and see if we are going to get the same result. So let's take any two real numbers. So let's deal with 2 and 4. So if we have 2 dot 4, you have to get 2 plus 4 plus 2 times 4, which is equal to 6 plus 8, which is 14. Now let's change the order of this and see. So if we have 4 dot 2, we are going to get 4 plus 2 plus 4 times 2, which is also 6 plus 8, and we are getting 14. So our operation we've been given is commutative, because if we change the order of the input we are dealing with, the order of the elements we are dealing with, our output is not changing. So we say that it is commutative. So let's see another example for the commutative property. Yeah. So we solved an example like this in the closure, and we are solving a similar one to here. So we've been given a table and we are told to determine whether or not the operation is commutative. So now, since the table is made up of a lot of, we have 3 elements, A, B, C, and A, B, C. It means whenever you do A star, let's say A star B, your result should be the same as B star A. So now let's go over and see. Let's go through the table and see if it's going to be commutative. So now we have here A star A is A. Okay. Since A and A are the same, if you change the order, it's still A star A, which is A. A star B is B. And B star A is also B. So it's commutative. A star C is C. And C star A is also C. Sorry, A star C is C here. Then C star A is also C. So it's commutative. Then we've already checked for B and A. Then B star B is C. Since B and B are the same, if you change it, you are still going to get B star B, which is also C. Then B star C is A. So let's check for C star B. C star B is also A, so it's commutative. We've already checked for C star A. Let's check for C star C. C star C is B. If you change the order, C and C are the same, so it will just be C star C again, which is also B. Hence, from this, we can say that our operation star is commutative. So our star is commutative. Because from the table, if you change the order of the elements you are dealing with, we are getting the same result. When we did A star B and we came to check B star A, our results were the same. So basically, that is it under the commutative property. If you change the order of the elements you are working with, your result does not change. That's all about commutative property. So if you have any comments or questions, please let us know in the comment section. And that will be it for today. So thank you very much for watching and see you in the next video. In the next video, we are going to deal with another amazing property, which is the associative property. So you can read about it before you watch the next one. So see you in the next video. Bye.